Hello everyone, welcome to my channel. I'm Subhrajit Asst, Assistant Professor in Narsimha Engineering College. So once again, I'm here to discuss about one more interesting temperature measuring instrument, that is optical pyrometer. Right, the radiation type pyrometer in the last video we have covered, and the working principle of radiation type pyrometer and the current one is different. In the radiation type parameters, based on the radiation of heat, we are going to measure the temperature. But here, different principle. What is the principle, sir? Principle is comparison of two lights. Simple comparison. So name itself, it's telling that optical means some lights related matter. It is light related thing. So comparison of two lights we are going to do here. Here, three types of comparison we will do. Three types of comparison. What are those three types of comparison? I will tell you slowly. But before going in details about the optical parameters, let me show you some interesting pictures. Right? You have seen like pictures, right? This one. This is a 100-watt bulb. Earlier days we are frequently using in every village, in every home, right? Now you see, this is a little bit light brighter. This is a little bit more brighter. And one case will come, the bulb is full brighter. In that full brighter case, this filament will be not visible. Where it is visible right now, and where it is visible a little bit reddish color. When the brightness is full, at that time this filament will not visible. Okay? Filament will not visible. Generally in the 100-watt bulb, 150-watt bulb, generally this kind of things we can observe very clearly. Now in this optical type pyrometers like this, some light comparison we are going to do. Light comparison. It is working on the principle of comparison of two lights. So three types of comparison I will do. I will tell what are those three types of comparisons, right? Look at this diagrams. Now in this diagram, three cases I have put. What is the first case, sir? So this is my, bulb. I have taken one filament bulb here, this one. This is filament. Right, here also this is same filament, and this one also filament I have taken. And this is the hot source whose temperature is to be measured. Whose temperature is how much I need to measure. This one and this one and this one. So three cases what here? Three cases when the hot source temperature or brightness is more, and filament brightness is less. This is one case. When the hot source brightness is more, filament brightness is less, right? That means we can easily compare the brightness between these two, this hot source and filament. Which one is more bright, which one is less bright, right? Second one is when the brightness of filament is more, but brightness of hot source is less. This one is more, this one is less. In that case also we can do comparisons, which brightness is more, right? This is the second case we will do. And how we will increase or decrease the brightness of the filament, we can understand through the construction of the optical pyrometers. After this I will tell. And third case is what? This is the hot source and this is the filament. Almost this brightness and this brightness are same, and the filament is disappear here. Disappear. It is not visible. It looks like one light. This region, it is looks like one light, but here two different light. Here two different light. So in this three kind of comparisons, three types of comparisons we are going to do in our current measuring instruments, right? Now let us come back to the construction of this optical pyrometer, right? Very interesting constructions, right? Sir, what is the arrangement? Now this is the hot source, you assume, whose temperature is to be measured. Hot body. It is written here, hot body. Now from this hot body, the light will be pass, right? Light will be pass, not radiation. Light will come. Radiation, obviously, radiation will be go, but we will much more focus on light of that hot body, light, brightness. Now this is the lens. This is the lens here we are using to concentrate all the light on this observation screen. Observation screen. Okay, all this observation screen, all the light will be focused on this observation screen. So if all the lights will be focused, then this color will come back to after some times. This color, right? This color will come back to this observation screen. This become, right? So now what we have done the arrangement here. Here we are using one filament bulb, and we are supplying the current through the battery source here, right? And here it is a rheostat variable resistor. For what purpose we are using? To control or to, I mean, increase or decrease the current value in this filament. To increase or decrease the current value, we are using a variable rheostat. It is a variable resistor named as or known as rheostat. If the resistance value will be less, then current more, brightness will be more. If the resistance value is more, then current less, brightness is less in the lamp. Like this arrangement we have done, right? And here is the eyepiece. Here is the eyepiece where we can see the I mean see the radiation. So brightness comparison we can do like this. Now the first case is what? Observe the first case. Suppose the filament is here dark, that means less brightness comparison to this one. Comparison to this one case, right? What I will do, I will slowly vary this rheostat either in this direction or in this direction. I will slowly vary this resistor so that current will be increased. In the circuit, current will be increased, and slowly brightness will be increased. Brightness will be increased. Now a time will come, this brightness and this brightness will be matched. If this brightness will be matched, then this filament will be disappear. Like this situation will come. That means one light only in the whole chamber, only one light will be visible. That means filament will be not visible, it will be disappear. In that situation, how much current is passing through the circuit, I can able to know through a proper current measuring instrument, ammeter or voltmeter, voltage measuring instrument. And later I can convert this current in the terms of temperature measuring, proportional to temperature measuring we can convert. Like this situation will come, right? Now another case I will take, sir. Suppose the filament is very bright and this is dark. Okay, now this is dark. Then what I have to do? I have to change the resistor so that current in the circuit will be decrease. If it decrease, brightness slowly decrease. Then in which situation right now here? In the situation the filament brightness is more and the hot source brightness, this observation screen brightness is less. So I need to decrease the current. So how to decrease the current? By varying the rheostat or varying the resistance here, by changing the resistance here. So slowly current will start to decrease and the brightness of the lamp will be, or the filament will be decreased, and one point will come, one time will come, again then both will be in the same brightness, again the filament will be disappears, right? Filament will be disappear, and once again we can able to measure the current, at what current this situation happens, and that C later converted into temperature. In this way we are going to measure the temperature. How this C converted to temperature? By using a suitable calibrated temperature scale. Suitable calibrated temperature scale. I already discussed how to prepare a suitable calibrated temperature scale in the previous videos. If you have not seen, please check those videos, right? So this three case comparison we have done here to measure the temperature. Very simple. The working is very simple. Construction is a little bit critical, but if you practice 2 to 3 times, you can easily remember this one, right? Coming to sir application, same application where we are using the radiation type thermometer, we can also use this optical type pyrometers, right? Most important, these both are non-contact type, no need to contact, and mostly if the hot surface is moving also, we can able to measure the temperatures, which is not possible in the case of contact type uh, thermometers, right? And coming to this is the application, several applications we have mentioned here. Metallurgical industries, power plant, where some molten metal is producing at very high temperatures. Those area we can use this instruments, right? Advantages is what? High accuracy, just like a radiation type, and simple and robust, very strong. This very rigid instruments, because it is exposing to very high temperature region. It should be very robust, right? And good for high temperatures, right? As already several times I mentioned, it is used in the high temperature regions, right? Around 3500 to 4000 degree Celsius, and it is no contact required for moving object also. It is suitable. And what is the disadvantage? Disadvantages is emissivity sensitive. Suppose the radiation, suppose the brightness of the metal surfaces or hot surface is very less. In that case, that it become very ineffective to measure the temperatures, right? But that means high temperature region not at all a problem. In low temperature region it may create some problem, right? And limited temperature range in the sense, suppose here we are observing this situation, right? Here we are observing the situations, so we can observe up to a certain limit of light. After a certain limit of light we cannot observe, we cannot see the situation happening, what is happening inside this chamber, we cannot see, right? So it should be work, here I have written, uh, typically used for measuring temperature within the visible light spectrum rays, right? Up to what spectrum rays the human can be visible. Okay, human can be visible, till that range of light we can able to measure. And suppose a very high temperature, just like in the summer days, the sun, in the naked eye it is very difficult to look the sun. In that situations, this temperature measuring instrument is failed to measure the temperature. So most advantages are there, few disadvantages are there, right? I hope this concept is very much clear to all of you. At least 1 2 times you watch this video and you will get the better clarity, right? This is the construction working, advantages, disadvantages, applications, everything I mentioned. So I conclude here. Please take care till then, and I will come back with you more interesting topics in the next video. So I'll stop here. Bye.